Pay attention to this class as we begin. If you must pass your exam tomorrow, you must listen attentively to what we're about to do. That is to you and every other person writing NECO tomorrow. Make sure you follow to the end if you must pass your exams tomorrow. Understood? So let us begin by reading the question. So this is Chemistry Practical NECO 2026. So let's begin by reading the question and see what it says. Okay. So the question says that A is a solution of a dibasic acid, H2OX. B is a solution of 1.00 grams sodium hydroxide in 250 cm cube. Put into a burette and titrate against 225 cm cube portion of B using methyl orange as an indicator. Repeat the titration 3 times, more 3 times, and record your results. Table 1.1. So the burette, the pipette is what you use to measure the base. The question says you should use 20. Question says you should use 20 or 25. We're asked to use 20 or 25. So in this space here, see that space? That's what you record. We are using 125. Put here 25.00. CM cube is already there. Understood?
Yes, sir.
Okay. So the endpoint for this year, based on calculations, is 25.2. So how do you use that 25.2 to form your table? I've taught you before how that is done, isn't it?
Yes,
So
sir.
I will start, the maximum capacity of the burette is 50. So I will start by putting 50 here, 50.00. So what I'm looking for is 25.2. So I will increase the rough maybe by 1. I will put here 25.30. So how do you get the initial now? You subtract 50 from 25.3. Initial will give us 24.70. So I can also come here by writing 50.00. What I'm looking for is 25.20. I will write it there. Here will now give me 24.80. I can use 50 or 3 if I want. Here is 50.00. Here is 25.20. Here is 24.80. So the last one, I can still use any number. I can write here as 25.20, 0.00, give us 25.20. You see that? So now that that is done, question Roman figure 1A, it says you calculate what? The average volume of AUs. So you are going to, so by doing this table, you have obtained what? 6 marks like this. So this one itself is 1 mark. The table itself is 5 marks. Are you saying it? That is 6 marks. Is that clear?
Yes, sir.
So let's calculate the average volume of AUs. So I'm going to have VA now. VA, you write it as V1 plus V2 plus V3 over what? Over 3, which is the average of the 3 titers. So I'm having 25.20 plus 25.20 plus 25.20 divided by 3. What would that one give to us? It will give us 75.60. If you add up, divide by 3, at the end of the day, your answer will give you what? 25.20 centimeter cube. You must put your units. Is that clear?
Yes, sir.
You must put your unit. So we have done with question A, Roman figure 1. Question A, Roman figure 2, he said we should write a balanced equation for the reaction. Look at the acid here. So how do I write it? A, Roman figure 2 now. A, Roman figure 2. So the acid is what? H2X. And the base is what? Sodium hydroxide. So what would this one give to us? So this one will give us sodium 2x plus H2O. I'll balance it by putting 2 here and putting 2 here. You see that? This is now the balance equation. Is that clear?
Yes, sir.
I've taught you before how to balance equations. So this is
Yes,
now
sir.
the balance equation. This one is plus, this one is minus, plus and minus. So since the acid is a dibasic acid, so it has a radical or anions of 2. That's why my exchange, that's why the sodium become a H2 ox. So that is that. So with that, we are done with question Roman figure 1A and 1B. Okay. So let's go to question B. Question B, Roman figure 1. It says from the result and information provided, calculate the concentration of B in mole per dm cube. Concentration of B in mole per dm cube. Remember, I told you we have two types of concentration. We have mass concentration and we have a molar concentration. The molar concentration is done in what? In mole per dm cube. Are you following?
Yes, sir.
So let's go back and see the data given to us for the base. Well, we need the concentration of the base now. In the base, they gave us 1 gram of it and 250 cm cube of it, right? For the base, for the B. So we are now asked to calculate the concentration in mole per dm cube. So what I will do is this. So B Roman figure 1 now. B Roman figure 1. So I'm having, you call the formula, given mass over molar mass. Okay? Is equals to the volume of the base over 1000 times molar concentration, which is what we are looking for. Okay, so you can see 6 marks there. If you quote the formula, they'll be able to give you a mark. So this is the molar mass of the base. So let's put it, and they gave us the mass of the base as what? 1.0. So I'm going to have B Roman figure 1. B Roman figure 1 now. So the mass is what? 1.00. The molar mass is what? 40. It's equals to 250 over 1000 times molar concentration. Are you there?
Yes, sir.
So what are we going to do from here? We cross multiply. I'm going to have 40 times 250 times molar concentration is equals to 1.00 times 1000. So my molar concentration will be what? I should make it the subject formula. Molar conc will be 1.00 times 1000 divide 40 times 250. So I multiply, what am I having here? 1000. If I multiply 40 by 250, what is that giving to us? It's giving us 10,000. So 1000 divided by 10,000, what are we having? 0.1. So I will say molar concentration, molar conc of B is simply what? 0.10 mole per dm3. So with that, we have answered question 1B, Roman figure 1. You see that?
Yes, sir.
We've answered that. So let's go to, I hope you are following up.
Yes, sir.
So let's go to question 1B, Roman figure 2. 1B, Roman figure 2, we say the concentration of A in mole per dm cube. Now, I have the volume. Now, look at the data I have now. I have my VA as what? 25.20 cm cube. The CA now, I don't have that. That's what I'm looking for. I have my VB, which is the volume of the pipette we recorded earlier, 25.00 cm cube. I have my CB, which was just calculated for now, 0.10 mole per dm cube. Right? Are you seeing that? So from the equation of written, our NA, mole ratio of the acid is 1, mole ratio of the base is what? is 2, based on the question we have written. Is it not?
Mm.
So with that, now I can now go to 1B Roman figure 2. So 1B Roman figure 2, we're going to have CAVA over CBVB is equals to NA over NB. So this one implies, I'm looking for CA, I don't know. My VA is 25.20, which is the endpoint, over CB, what we just calculated for, 0.10, VB is 25.00, NA is 1, NB is what? Is 2. You see that?
Yes, sir.
So when you are solving, don't put the sign like this. It's not allowed in chemistry. Don't put the sign of cross multiplying. Although we know we are cross multiplying, but don't put that sign there. Is that clear? So I'm going to have
Yes, sir.
CA times 25.20 times 2 equals to 0.10 times 25.00 times 1. So let's make CA the subject formula. My CA will give me what now? 0.10 times 25.00 times 1 divide 25.20 times 2. If I multiply the, what am I having? 2.50. If I multiply the denominator, what am I having? 25.2 times 2, that will give us 50.40. If I divide, what am I having? 2.5 divided 50.4 give us 0.0496 mole per dm cube. This is not the concentration of A now in mole per dm cube. Is it understood?
Yes, sir.
So let's go to the next question. So let's look for question 1B Roman figure 3. Yeah, there we go. 1B Roman figure 3. 1B Roman figure 3. It said calculate the molar mass of A given that solution A contains 4.8 grams per dm cube of the acid. So there's a relationship between mass concentration, molar concentration, and molar mass. So I would say, let's code the formula first, then we'll go back to solve it. We have that molar mass, which is what we are looking for. Molar mass is equal to mass concentration over molar concentration. Okay? So the mass concentration is given to us now as what? 4.85. Okay? So let's just do it here. I'm going to have 4.85 as the molar mass concentration. What about the molar concentration? What we just calculated for now? 0.0496. So let us divide now. 4.85 divided by that. We're going to have approximately 98 grams per mole. That is not the molar mass. Understood?
Yes,
So
sir.
what if you calculate? I'm going to have 97.776. So that's approximately 98 grams per mole. Is that clear?
Yes,
So
sir.
like I said, if you must pass, follow this video, post to your friends. You must get 50 over 50 tomorrow in this exam. Then question 1C, it says a standard solution of sodium hydroxide cannot be made by weighing out accurately a given mass of the solid and making it up to the required volume of solution. Give reasons for your observation. It's simple. Sodium hydroxide is not a standard solution because sodium hydroxide, let me write that, sodium hydroxide, let me put it in symbols, is not a standard solution. Why? Because it is deliquescent. Okay? Because it's what? It's deliquescent. So that is why you cannot use it. Cannot measure it accurately. Understood? So that is
Yes, sir.
question 1C. That's question 1C. So let's look for where we go now. Question 2. Question 2. This is question 2 now. Let's deal with this. Now, let's read the instruction first and see. Let's read the instructions. Look at what the instruction says. It says you are advised to adhere strictly to the structure given. All observations and inference must be recorded in table 1.2. Identify gas or gases given off. You are provided with a sample C. Carry out the test on it. Okay? Sample C from the yellow paper is CuXO4. That is sample C. Okay? CuXO4. It's a blue substance. Okay? Now, what happened when you add 5 cm cube? Look at C. C now plus 5 cm cube of distilled water. Shake thoroughly. Divide solution into 3 portions. So what happened? C dissolves completely. When you do that, when you do what you're asked to do now, completely in what? In water. So you must learn to manage this space. Okay? C dissolve completely in what? In water. What does that make C? C is a soluble salt. That's what make it dissolve completely in water. C is a soluble salt. Is that clear?
Yes, sir.
So Roman got 2 says when you soluble, what you have is just filtrate. You no longer have residue. They're not asking now. So the first portion, divide into 3. That's what the question says. Divide it into how many portions? Into, and just look at it here, divide into 3 portions. So it says to the first portion now, add sodium hydroxide in drops. So when you add sodium hydroxide in drop, we're going to have a pale blue gelatinous PPT. Okay? So what does that tell us? When anything that has blue solution, that is where you mean copper 2 ions is present. Is that clear? What it means is that copper 2 ion is present. So what happened when you put more excess sodium hydroxide? PPT insoluble means excess sodium hydroxide. So meaning copper 2 ion continuing to be there, present. Is that clear? It means copper 2 ion continues to be, yes. So what next? He said to the second portion now of the second portion, I said 3 portions, we have used the first one. The second portion now said add dilute ammonia in drops. Okay? Add dilute ammonia in drops. So we're going to have blue. Okay, let me say pale blue. Pale blue, pale blue. Let me clean and rewrite it. I'm going to have pale blue PPT, pale blue PPT form. So what does that tell us? Copper continues to be there. What happens when you pour excess ammonia? So PPT dissolves to form deep blue solution. Okay? It will dissolve. You now see a very dark, deep blue or dark blue solution when you that's why you experiment it. So what does that mean? It means that copper is confirmed. Copper 2 ion confirmed. That's what it means. Okay? Copper 2 ion is what? It's confirmed. Down, what happens? Now, what happens next? We are confirmed copper. So to the third portion now. Want to test for the third portion. Say add barium chloride solution. What are you going to see? You're going to see white PPT form. I'm going to see white PPT. What does that tell us? There are 3 radicals you present. SO4 2 minus can be there. XO3 2 minus can be there. Okay. CO3 2 minus can also be what? Can also be there. Or X2 minus can be there. Are you getting it? So these are the possible radicals we see. Then, what happens when you add excess dilute HCl? PPT, insoluble. Nothing will happen. Insoluble. So what that means? It means that SO42 minus is confirmed. That is what it means. SO42 minus is confirmed. So this is the solution to question 2. And this is how you are going to see it tomorrow, whether the devil like it or not. Understood?
Yes, sir.
So at the end of the class, I will send you the link, send to your friends, let them watch and make a good use of their time tomorrow. So let's go to question 3. Look at question 3 here. Question 3A. So you have to determine the concentration of a solution of tetrasulfuric acid by titrating it against sodium carbonate 4 as a standard solution. You say, name an indicator you may use. So the H2SO4, our H2SO4 here is a strong acid. Do you understand? It's a strong acid. While the sodium carbonate, NO2CO3, is a weak base. It's a weak base. So what happens when you are titrating a strong acid against a weak base? Which indicator is suitable? You are using what we call methyl what? Orange. Yes, you are using methyl orange. Okay? It says state the color, okay, of your choosing indicator in the base. When you add methyl orange to the base, what color are you seeing? You are seeing a what? An orange what? Color. Okay? So at the end of the endpoint, what do you see? You see a purple what? Color. At the end of it, if you have done titrations, all these things, you don't have to read it. They will be visible in your eyes. Okay? You see purple color. Have you done titration before?
Yes, sir.
When you add methyl orange to base, what color does it give you? An orange color, right?
Yes.
When you titrate and you obtain the neutralization point, the color changes to what? From orange to what? To purple. Is it not?
Yes, sir.
You say, why was the indicator used? Why we use indicator? To determine the color change at the endpoint. You determine color change at the what? At the endpoint. Because if you don't do it, you don't notice whether the color change. You just be acid into base. Both of them are colorless, right? You don't know anything, whether there's pressure points have been achieved or not. So to determine the color change at the endpoint. So this is question 1.3a. Okay, so let's go to Roman figure 4 of it. Let's see what the question says. Roman figure 4 of it. Let's see what it says. It says, state 2 precautions to ensure accurate burette reading. Now, the first precaution, there are many. Let me just give you 2 here. Many. Remove the funnel, okay, from the burette after use. Why? There's a reason, although they didn't ask us to state the reason. Okay, they ask you to state the reason. To avoid increasing the volume of the acid. Okay, that is why we must remove it. Because they are droplets. If you leave it, there will be some little drop that's going into the burette, right? That is why you should take it away. Okay? That's why you should take it away. Then another reason why to apply accurate results is that you will rinse the burette with the solution contained in it. And what is that solution? Who is that solution? Is the acid. Now, if you don't raise it now, before you can use the burette, you first of all wash it with water, right? Meaning there's water inside the burette, isn't it?
Yes, sir.
So if you don't raise the burette with the acid, and you add the acid on it like that, the water inside the burette, the small water left inside the burette, will dilute the acid. As such, you will not have a perfect endpoint. Okay? You will not have
Yes,
a
sir.
perfect endpoint. Then Roman figure 5. It says name the type of reaction that takes place between steroid acid and sodium tricarbonate 4. It's a neutralization reaction. What's the neutralization reaction? It's a reaction whereby the acid reacts with what? With base to form salt and water. Okay? That is neutralization.
Yes,
so this is the acid, this is a base, but it's a weak base. It doesn't stop the fact that it's a what? It's a neutralization reaction. Is that clear?
Yes, sir.
You say mention the apparatus used in the laboratory to determine the volumetric composition of water. Who is that? Hofmann. The apparatus is Hofmann voltameter. That's the apparatus we use, voltameter. Okay? It's Hofmann
Yes, sir.
voltameter. Then, numeral 2, the instrument to keep indeterminate supply of gases is KIPS. We call it KIPS apparatus. KIPS apparatus is what we use. Okay? Is what we use
Yes, sir.
to supply gas continually to anything we want. Now, why is the solution of silver 2095 stored in amber color reagent bottle? So if you are very conversant with your chemistry laboratory, you will notice that anything silver is stored in a dark reagent bottle. Or some people use the word amber reagent bottle. Why? Because silver nitrates, let's write it in symbols. Silver nitrates, NaNO3, is easily decomposed by sunlight. Okay? It's decomposed by what? By sunlight. That's why they are stored in amber or dark reagent bottles. Is that clear?
Yes, sir.
So this is the entire solution to the chemistry you are writing tomorrow by 9 or 10 o'clock. So if you take, like I said, post to your friends, post to people, let them watch tonight. Then ask them to subscribe to our channel, STEM Up Africa, to get more exciting videos like this a day before the exams. Understood?
Okay, sir. Yes, sir.
Yeah, so what I will do now, I will upload it and send you the link so you just watch it at your own, so that you can, tomorrow you can just PCC it as you want. Okay?
Okay. Yes, sir.
All right, so hold on, I will send it tonight. Don't sleep, oh. Don't sleep. Although you've seen how I've done it, right? You've seen how I've done it. So when I send it to you, just go through it so you can grasp it thoroughly. Is that clear?
Yes, sir.
All right. So see you tomorrow.